everyone. I am Dr. Jagadha, Professor and Head of the Department Mathematics, Institute of Aeronautical Engineering. The subject would be selected for this video lecture is probability and statistics, in which the topic what we are going to concentrate normal distribution and normal curves. What are the subtopics we are going to discuss in this video lecture? Definition of normal distribution and mean of normal distribution, variance of normal distribution, and normal curves. These are the four subtopics we are going to discuss in detail about them. The normal distribution, the concept which was first discovered by the English mathematician de Morgan in the year 1733. This normal distribution, in other way we can call it as Gaussian distribution also. Totally so many distributions are there, binomial, Poisson, and among them normal distribution is also one among them. This binomial distribution, that extension, that is only normal distribution. In the binomial distribution, P and Q, that is P, that is probability of success, that is denoted by P. Q is the probability of failure. Those values will be very small if we apply this binomial distribution formula. But whereas coming to the picture, the concept of normal distribution, this P and Q values are not small. That's what here it is written, neither P nor Q small. And one more thing, the normal distribution is therefore derived from the binomial distribution by increasing the trials indefinitely. The definition of normal distribution. What is a formula which is defined by normal distribution? A random variable, capital X, compulsory the random variable, they are denoted by uppercase letters, that is what here capital X is written, is said to have a normal distribution if its a density function or probability distribution is given by f of x mu sigma. X at that what particular point x lies between from which range to range. Mu, it's nothing but a mean, sigma standard deviation, which is equal to 1 by sigma square root of 2 pi e power, minus is there here, minus into x minus mu the whole square divided by 2 sigma square. The x, because here the thing that the density function, x mu sigma, x from where to where? From minus infinity to infinity, and here mu also minus infinity to infinity. Here the sigma is standard deviation is positive, that's what here greater than 0 which is written. Where mu is the mean and sigma is the standard deviation of x. Using this normal distribution defined formula, we are going to find mean of normal distribution. The derivation we are going to concentrate. Prove that. The question what type of question which will be asked regarding this derivations of normal distribution. So there is a possibility of asking like this. Prove mean of normal distribution which is equal to mu. Mean itself, which is denoted by mu, Normal distribution mean also itself only, that is mu. So we can see it. This is, we know it. Normal distribution defined formula. Consider the normal distribution with B, sigma. So now starting itself your doubt is coming. Because there is no, the previous symbol here it is there. The defined one x mu sigma is there. How the suddenly that the letter, the variable B is coming here? To prove that mean of the normal distribution is mu. Again in the formula also mu, there is a chance of committing mistakes. That is the reason here in the mu, where is the formula? Time being, we are substituting instead of mu, in that particular place, we are taking the variable B. Then we can see it. What is written, this is the rough column. We put it in the fair, f of x, mu, sigma, which is equal to 1 by sigma square root of 2 pi e power minus of x minus mu the whole square divided by 2 sigma square. The mean mu equal to e power x, which is given by, yes, e of x. Mu equal to e of x, that is expectation of x. The formula is integral minus infinity to infinity x into f of x dx. We have written. This is completely just in the PPT, the way of presentation which is done. This is a rough. First we are discussing. This is the fair place, that is the student should present in the classwork, in the exam, what to be present. Here in the PPT it is written. Mu equal to integral minus infinity to infinity x into f of x dx. Now this f of x, which is, we are going to replace it by our defined normal distribution formulae. Yes, here we can notice it. What I am circling here, the circled one, which is replaced by our defined normal distribution formulae. What are the changes we have done it? We can do the comparison. This is the current, the line, the previous line. What are the changes we brought in? Just we have taken here this 1 by square root of 2 pi just in front of the integral we have kept it. Anyway, we are going to do integration with respect to x only we are going to do. So there is no x term, nothing wrong in it. We can place it before the integral. So we placed it. The next one, how to solve this integration. It is a complicated one. It's not very simple integration. If it is only integral x dx, easily we will tell of x square by 2. But here exponential is there, which is multiplied by x term is there. So substitution, is there any possibility is there? We can think over that. So x minus b by sigma equal to z. So just now we have seen it. Here I told the mu, to avoid the confusion, we have taken the variable, the letter b. So x minus b the whole square divided by 2 sigma square. This particular place. That x minus b by sigma we are assuming as capital Z, small z. In this particular place we are going to replace it. Before that, x minus b by sigma, which is equal to z. Sigma is common LCM, that is. Split, we can write it x by sigma minus b by sigma, which is equal to z. Fine. Now, both the sides we are going to do the differentiation. If we do here, some confusions possibility is there. To avoid that, in the rough we rotate completely more in a simplified form, x by sigma minus b by sigma equal to z. Then we can do the differentiation here. Then x, the differentiation is dx divided by sigma. The z, the differentiation is dz. So the dx equal to sigma dz, just the cross multiplication. Here also, from which we can extract x minus b equal to sigma z. So many actually simplifications we have done it. Now, the main idea is this complete integral with respect to x we have to do it. Now, our aim is complete the one in terms of integration with respect to z we are going to do it. For which this x is replaced by, from here what we can obtain x equal to b plus sigma z, that is replaced. This 1 by sigma is written as it is, e power minus also as it is, and the 2 also written. So the leftover is x minus mu the whole square divided by sigma square. So the time being we have taken mu as b. Fine. So x minus b the whole square divided by sigma square. Without the square we assumed as z. Then this particular place will become a z square. Then dx, it's nothing but sigma dz. Substitution method we adopted. So the students community, what they have to remember while this particularly the derivation part comes in mathematics, key points we have to remember. The definition is fine. To derive, first this point to be remembered. That is integral minus infinity to infinity x into f of x dx. Here f of x which is replaced by normal distribution formula, and what assumption we adopted here. If you forget this assumption, it is difficult to proceed the derivation. So any derivations in mathematics, key points remembering is very, very must for everyone. So now this is the last step. Fine. Now 1 by square root of 2 pi integral minus infinity to infinity and sigma z plus b as it is. This sigma it is getting cancelled. The leftover e power minus z square divided by 2 dz. Here two terms are there. Sigma z is there and b is there. Two terms. So we can write the complete integral, first integral plus second integral. That is, first integral contains sigma z. The second integral contains this b into other terms. So we have written here 1 by square root of 2 pi integral minus infinity to infinity sigma z e power minus z square by 2 dz plus 1 by square root of 2 pi integral minus infinity to infinity b e power minus z square by 2 dz. So here we can see it very clearly. Sigma we have taken out. So z into e power minus z square by 2 dz, and this b we are bringing out plus b by square root of 2 pi integral minus infinity to infinity e power minus z square by 2 dz. The next step, the complicated integral. We adopted the substitution method in such a way, in a simplified form, we made it first integral plus second integral. Again, these two integrals we have to solve. We are going to take help or concept based on even function and odd function. So for which, this is the function. First integral, first we are checking whether the function is even or odd. The function is written. The z which is replaced by minus z. That means wherever left or right side of that equal sign, z is there, better we will replace it by minus z. So here also it is there. It is replaced by minus z. Here e power minus, we didn't touch at all. Just we have written it. Whereas here z is there, minus z the whole square divided by 2. So now f of minus z, which is equal to minus z e power minus the negative the square. We know it is positive. So minus z square by 2. Here we started the question. What is dominating in our question? This is the function. We replaced it and we are comparing this both. It is there. Only the thing is there. The complete function which is repeated again with the opposite sign negative. That we noticed it. That is, it is an odd function. There is a formula, that is, this is a formula. Minus of any function. Suppose f of x is there. The x we are replacing it by minus x. The result if we obtain minus into f of x, then it is odd function. So we observed it is an odd function. And one more thing, our integral, the value range from minus infinity to infinity. That point also very, very important. So there is a formula, that is any function we defined that is an odd function if it between the range minus infinity to the infinity, the integrand value is 0. That concept using the first integral is completely vanished, doesn't exist. Now the next target is the second integral. Here also this function we have to check whether it is odd or even. Yes, this is the last step. We got it. Now, this is, we obtained odd function. And in this particular, the integral, the range limit, it is 0. Now, second one, the function is this one. So, here we are going to test whether it is odd or even. Say the z which is replaced by minus z equal to e power minus, only the z part only we are touching, minus z the whole square divided by 2. So f of minus z which is equal to e power minus z square by 2. Here we can write f of minus z equal to This is only, we started with the function which is given in the question. After replacing also, the same only it is repeated. So, f of minus z equal to f of z. So, it is an even function. And the limit range also minus infinity comma infinity. Then the second integral value is, so this is the one, the function we tested. So if it is an even function, if it satisfies this condition, then it is declared as even function. And one more thing, it's a very important point, the range limit minus infinity to infinity, everything it is satisfied. Then this minus infinity to infinity, we can write 2 into integral of 0 to infinity. So minus infinity to infinity, it is written as 0 to infinity e power minus z square by 2 dz. So we can see it just in the rough, we kept it. What is the even function definition? So now, this is actually the previous slide. The last step, once again, it is written. We know it. The first one, the integral is 0 because it is an odd function. The second one is here. This is completely replaced by what we obtained it here. So last step it is written. Now this 2 is there. It is become b into 2, 2b. Remaining everything we have written as it is. Again, this to be solved, this integral. So integral 0 to infinity e power minus z square by 2 dz. This integral value is gamma function, square root of pi by 2. So with that, with the aid of that formula, so we are going to solve the integral. So now this is written as it is. This is nothing but root 2 pi by root 2. Now here this is root 2 into root 2. This both are getting cancelled and this is cancelled, which is equal to b. The starting of that derivation only is time being, to avoid the confusion, mu place we have taken b. So b should be replaced by mu. So this is the normal distribution formula. So this is the question which is put. We are asked to do it. We are asked to derive it. The mean of the normal distribution, that is mu. So very clearly the explanation which is given. So now the mean of the normal distribution is mu. Now variance of the normal distribution, we can focus it. How the question will be asked? Prove variance of normal distribution, which is equal to sigma square. If it is only sigma, that is, we will call it as standard deviation. Here we are going to take the formula integral minus infinity to infinity x minus mu the whole square f of x dx. Our f of x, we are going to replace it by normal distribution formula. So here we can say it, here which is written as it is. So the f of x, which is replaced by the normal formula. So after replacing it, that is the normal distribution, the defined formula we substituted in the particular place of f of x, we obtained. Some simplifications we are doing. Here 1 by root 2 pi, it is kept front of the integral. integral minus infinity to infinity into x minus mu the whole square divided by 1 by sigma e power minus of x minus mu the whole square divided by 2 sigma square dx. So now this, we have to solve the integral. Same substitution method what we adopted for mean of the normal distribution, same procedure here also we can do it. So x minus mu by sigma we are assuming as z. So here mu should be there. So we are writing comfortably to make ourselves comfortable, x by sigma minus mu by sigma, which is equal to z. So we will do the differentiation both the sides. X is dx divided by sigma. Z differentiation is dz. So now the sigma we are bringing here. So dx equal to sigma dz. From here better we can write it mu. So x we can write it x minus mu equal to sigma z. This we are bringing here. We will do the comparison. 1 by square root of 2 pi integral as it is written, whereas x minus mu, it's nothing but sigma z. So this particular place which is replaced by sigma z, the square is as it is. 1 by sigma as it is. E power minus as it is. Whereas even the 2 also as it is. This particular part what I am circling. Yes. This part x minus mu the whole square divided by sigma square. We assumed x minus mu by sigma has z, but here square is z, that is the reason here z square. Dx it's nothing but sigma dz. Completely in terms of, with respect to x we have to do the integration, we completely using this substitution, the assumption, what we assumed. Integration with respect to z, we changed it. Yeah, here we can see it. The sigma square, here we have taken, that is before the integral, because we are going to do integration with respect to z. So z square into e power minus z square by 2 dz. This function, we are going to test whether even or odd. Before mean also, what way we tested, similar way. So this is the function what I circled here. Yes, we have taken. Z is replaced by minus z. So here, one more term also should be there. Minus z the whole square into e power minus the z which is replaced by minus z the whole square divided by 2. It is missing here, z square is there. So minus f of minus z equal to z square into e power minus z square by 2. And we are noticing now, this is, we started testing the function, we ended here. Both are same. The meaning is f of minus z equal to f of z. Then we know it. This is the satisfactory one for even function. And one more thing, we have to check our limit range also. Our limit range is minus infinity to infinity. Both. Then the integral, we can write it instead of minus infinity to infinity, we can write 2 into integral. So it is an even function. So here that's the reason here minus infinity to infinity, 2 into integral 0 to infinity e power minus z square by 2 dz. Here also the term actually it is missing, that's what I am writing. Yes, here it is written correctly. The 2 it is here. So sigma here we can notice it here. Sigma square, the front of the integral we didn't touch at all as it is written. Sigma square divided by square root of 2 pi. Now this function we obtained, it is an even function. So 2 into integral 0 to infinity, it is written as it is. So now this we have to do the integration. Again one more substitution. So it's a very complicated integral. First some assumption we did, little bit we made it easy. Again now this is also it's not an ordinary one. One more substitution we are doing. As it is a derivation part, we have to remember while doing the derivations, here z square by 2 is there, that we are going to assume as t. So both the sides we are going to do the differentiation. So z square 2z dz divided by 2 dt. The 2 getting cancelled, z dz equal to dt. So dz by dt, here we can see it, dt by z actually it should come, because here z square equal to 2t, z equal to square root of 2t, that's what here it is written. Now integration with respect to z, our aim is completely with respect to t we are going to change. This no changes. This 2 actually here we can see it. Z square is there. This 2t it is written. Next e power minus as it is. Z square by 2 what we assumed is t written. Dz it's nothing but dt by square root of 2t. Easy way we can see it. It is, this is nothing but from here the connectivity it is written. This part also the connectivity of here. So completely with respect to t we changed it. Now this root 2 and this 2 getting cancelled. The remaining here integral 0 to infinity. The remaining part t into e power minus t dt by root 2t. Yes, in terms of t, completely the integration it has been changed. Now this root 2t it's nothing but a t power 1 by 2. Here we can see it. 2 sigma square divided by square root of pi integral 0 to infinity root 2t e power minus t dt. So the t power 1 by 2, here it is there. Nothing wrong in it. 1 by 2, we can write it 3 by 2 minus 1. Both are same. So that concept here 3 by 2 minus 1 we have written. Mathematically it is correct. Why suddenly we have taken? Because there is a formula in the gamma function integral 0 to infinity x power n minus 1 into e power minus x dt equal to gamma n. So that is the background. That is the idea. We got it. Because of that, or due to that, here we made it that 1 by 2 in the place we wrote 3 by 2 minus 1. The picture is very clear now. The formula which is, here x should be, the formula completely in terms of x. Ours is in terms of t. That's the difference. Then here n is there, our n is 3 by 2. The formula n minus 1, ours is in the problem 3 by 2 minus 1. To equate our integration to this formula purpose, the 1 by 2, we have written 3 by 2 minus 1. Now, very clear picture. What is n? Yes, n is nothing but 3 by 2. So now, t power 3 by 2 minus 1 e power minus t dt equal to gamma of n. So gamma of 3 by 2. Here we can. So now gamma of 3 by 2, 3 by 2 we can split 1 by 2 plus 1. Both are same. Gamma of n plus 1 equal to n into gamma n. So here comparison. So we are going to substitute to this right side of the formula. We are doing comparison. Our n is nothing but 1 by 2. So 1 by 2 of gamma of 1 by 2. This is as it is. This complete integral, the value what we obtained is, this is the 1. But we are not writing this one. 1 by 2, yes, here it is there. What about root pi? Root pi, it's nothing but, this is the gamma of 1 by 2 value. So root pi getting cancelled, 2 getting cancelled, we obtained sigma square. So sigma square is the variance of the normal distribution. So where we started? Here we started with our sigma, that is infinity minus infinity to infinity, x minus mu the whole square, f of x dx. And we obtained the thing, what we have to prove it, sigma square. Yes, we proved it. So we can see it, the two derivations we have done it. One is mean of the normal distribution. That is what we have to prove is mean of the normal distribution is mu we have to prove. So to avoid the confusion purpose, we have taken instead of mu as b, and we proved it also. Here we proved it, the b, that is mu, and variance also we completed. Yes, we proved it. Now the normal distribution, mean and variance we completed. This topic, normal curves. Yes, it's a very interesting topic, normal curves. So to find the probability of density of normal curves, here we can see a picture, the normal curve, a line, a vertical line which divides the curve equally symmetrically. That means how much this area, here also equal area. Total probability we know it is 1. That means this area is 0.5, here the area is 0.5. Z equal to 0. That is at the mean. Here there is a formula. We will see it now while doing the explanation part. The first one is, if a point is there, Z1 is greater than 0. Z2 is also greater than 0. Greater than 0, here is a point, Z equal to 0. This complete part is right side, positive values. Here left side negative values. Our question is Z1 and Z2, 2 points are there, they are positive. Then we have to take the decision. It is given, they are positive. Then automatically our hand should go towards the right side. So we can see the next diagram. Z equal to 0. Z1, we placed it right side. Yes, the point here, we have drawn a vertical line. Z2, that is also right side. Yes. What is our question? The question is, first they put a condition. That is Z1, Z2, 2 points are there. The 2 points are positive. So we moved to the right side. Then the probability of Z lies between Z1 and Z2. This point to be noted. Z lies between Z1 and Z2. Then here is there. This particular area we want it how much? That is our question. With the help of this normal curve, we are going to find the normal distribution table also it is there. But in this video lecture, how the points are plotted, how to find the area, formulae we are going to discuss. Yeah. The same question only. The before slide, the steps I explained. This is the diagram. It's a fair diagram which should be presented in the exam. Question is there. What they are asking us, Z lies between Z1 and Z2. Fine. So this area you can see that yellow color of the painting, the shaded one to be found. Simple concept. We want this, the shaded area, 0 to Z2. First we will find the area. Fine. Then this part it is there, we will subtract it. The remaining is shaded area. That concept we used it here. That is modulus of area of Z2 minus area of Z1. We can see the previous slide. So here you can see it. The points are written. Yeah, this is the problem. First it's a rough diagrams. That is the background of the fair diagram. First normal curve. Next the points are plotted. This is the fair diagram. This area to be found. That is the area of Z2 minus area of Z1. We will move to the next one. Your normal curve is ready. This is our condition. Z1 is less than 0. That is negative. Z2 is greater than 0. Positive. Yes. First we will plot it. Z1 is selected in the left side because it is less than 0. Fine. The vertical line which is drawn at the point Z1. Z2, that is positive, greater than 0. Fine. What is the question they are asking us? Z lies between Z1 and Z2. That means this shaded part. We have to find out the area. Very simple thing. Fair diagram we can see in the next slide. Yes. This is the fair diagram. Point is the yellow color is the shaded one. 0 to Z1 area we will find. Plus 0 to Z2 we will find the area. plus area of Z2. Very simple thing to understand. The student should understand more. The level to be increased. That is the reason the previous slides also step by step the diagrams are shown in this video lecture. So the next one, yes, normal curve is ready. Now our question is the condition. Z1 is greater than 0. Yes, my hand, it's going towards the right side. The reason is it is positive. You can see it here. Yes, the right side, the point is plotted. Here we can see it. Yes. Now, probability of Z is greater than Z1. That is, the point is there, the right side of Z1. This point is there which is right side. Here already the formula which is written. In the fair diagram we can discuss. Here we can see it. Yes. Z1 we plotted and Z greater than Z1. Here Z1, this is right hand side of Z1. This is left hand side of Z1. This particular point. Greater than right side of Z1. So this is the shade. It goes on. That shaded one, yellow color one, we made the difference because this is goes on up to infinity. This goes on up to minus infinity. The derivation part also we have seen lies between minus infinity to infinity. Now, and one more thing we have to remember. Area if you are taking, this is 0.5. This is 0.5. Total probability is always 1. Now, this complete 0 to whatever it is there, total area is 0.5 only. This is to be remembered. There is no change at all. We can't change the mathematical laws, what it is defined. So, it goes on. Our work is now the shaded, the yellow color one which made it here in the diagram, that particular shaded area we have to find. So the total is 0.5. Yes, in this part we will remove it. The total, this part removing, shaded one we will be getting. That is the reason 0.5 minus area of Z1. The next one we can see it. Yeah, the curve is ready. The question is Z1 less than 0. Less than. So we have to go to left side. Yes, correctly we plotted. At the point Z1, the vertical line which is drawn. Next, they are asking right side of Z1 to be shaded. Here Z1 is there. For Z1, the point, this is left side. This completely right side. Greater than right side of Z1. Easy way. It is a very simple language. I am not speaking mathematically. The English language actually I am speaking right side. Greater than, it's mathematically it will go. If I tell right side, the language communicating English I am using. The difference it is there. So the right side of Z1. Completely this to be shaded. Full covering. Up to where? It goes up to infinity. This shaded part we have to find the area. So we can see it completely. All this it goes up to infinity. So completely the half part which covered 0.5, because this is 0.5. Then 0 to Z1 to be, that area to be added. So this is for this particular normal curve 0.5 plus area of Z1. We will see the fair diagram. So this is the diagram to be presented in exam. So I am requesting all the students, the previous slides or the steps how to get this fair diagram. In the exam only, this is the only one diagram to be presented. Now we can see the shaded part completely. This is 0.5. This is area of Z1. We'll see the next. Yes, our normal curve is ready. Yes, now what is the question we have to focus? Yes, Z1 is greater than 0. Fine. Yes, our line is ready. Z equal to 0. Z1. We placed the point Z1 on the right side because it is positive, greater than 0. Here, the question which is asked the left side, less than Z1. Here is my point. The point is Z1, left side. This is completely left side. All left side. This part is right side of Z1. The complete this part, it is covering. The area is 0.5. So I can draw it. So this is 0.5. It goes on up to minus infinity. So 0.5 and 0 to Z1. The area we will find. So area of Z1. So we can see the fair diagram for that the previous one. Yes, Z equal to 0, Z1. So completely the full part, it goes on 0.5 and this is also calculated area of Z1. So the next one is if Z1 less than 0. So the normal curve, it is a line which divides the normal curve symmetrically equally. 0.5 area, 0.5, total probability is 1. What they are asking us to do it? Yeah, we can see it. Z1, which is placed in the normal curve at the point Z1, which is placed the left side of this vertical line. Z1 is ready. They are asking the left side of Z1. Here is our point Z1 for the Z1 which is left side. This is left. This complete part is right. So we want it, the left side, to be shaded. Goes on. It should be shaded. Shaded part area only we are concentrating. 0 to it goes on, the half part of the normal curve is 0.5. Yes, that we have written. And what I am circling here, this particular area to be removed. Then area of Z1 to be removed, then the shaded part will be getting. Yeah, we can very more clearly we can understand. Yes, you can see it. Yes, this is the yellow color one, the shaded one. This completely, it goes on, full complete this part is 0.5. This part, we removed it. Then 0.5 minus area of Z1. Yes, we will come to a conclusion of this topic, normal distribution and normal curves. The first, the normal distribution, the formula we discussed. That is 1 by sigma square root of 2 pi e power minus x minus mu the whole square divided by 2 sigma square. This point is very, very important. X lies between minus infinity to infinity. Mu lies between minus infinity to infinity. And sigma, that is our standard deviation, which is greater than 0. So mean of the normal distribution, it's nothing but mu. To avoid the confusion, in the formula, little some changes we did. Instead of mu, we have taken b. And we used the concept of odd and even functions. So the mean, when we are finding the mean, or the first integral, it has become odd function. So the limit range minus infinity to infinity, and if it is odd function, the integral value is 0, whereas if it is even function, then the integral, that is minus infinity to infinity, which is written as 2 of 0 to infinity. That concept we used it, and the mean of the normal distribution is mu. The second one we found variance of the normal distribution, for which we used the formula integral minus infinity to infinity x minus mu the whole square f of x dx. F of x, which is replaced by our normal distribution defined formula, and we proved it, that is sigma square is the variance of the normal distribution. And normal curves. The normal curves, 6 different types of curves. First, this is the first curve. So here we have seen it, that is z lies between z1 and z2. This is the formula, which is the area of z2, which is subtracted this area of z1, we got it. The second one, here area of z1 plus area of z2, this is the, for which this is the fair diagram. And the third curve, it's a very different curves, we discussed it, that is here, it's a different one, 0.5 minus area of z1, that is here the z1 which is placed. Why it is shaded the right side of shading 1? Because of this greater than symbol. And one more curve, here it is also a different curve. Here we can see it, the z1 which is there in the left side because of the less than symbol, the shaded part 0.5 plus area of z1. And one more curve, we discussed it, 0.5 plus area of z1. The last one here, 0.5 minus area of z1. So completely we discussed mean, variance and normal curves. Complete detailed picture which is given, and more other video lectures also is there about normal curves. So thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.